Let's write about quadratics real fast. First things first, can you tell me what factored form is for a parabola? And what does the equation look like in factored form? Usually x minus. And there's also going to be something out in front. I'm going to change the names of the variables here a little bit just so that I don't overlap. I'm going to call this a times x minus d times x minus e. And you're right, it mostly just tells you about the two x-intercepts. Next question. Do the x-intercepts tell you anything about the vertex? That's true. Is that only true about x-intercepts, or is there a more general version of that statement that you can make? That is absolutely correct. And the reason that I grilled you on it is because that statement right there has been relevant on a Blue Book test. Okay, lovely. We've got everything that I want to down about factored form. What about vertex form? Could you tell me what vertex form is off the top of your head? Traditionally H. Yes. Why do we use specifically H and K for this? Do you remember how function transformations work? If we want to translate something right by H and up by K, we have f of x minus h plus k. Vertex form is literally just a parabola that's gone through these translations. Many formulas on the test are actually just a function that's gone through function transformations. Vertex form, there's not a lot we can get out of it. It tells us where the vertex is, but it's useful for a lot of reasons. Then standard form is, of course, y equals ax squared plus bx plus c. And vertex or standard form tells us a lot of things. What are some of the things that standard form tells us? C is indeed the y-intercept. That's true for all of the A's, in fact. They're all the vertical dilation. Could you tell me how to figure out how many solutions a parabola has from vertex or from standard form? Do you recognize the phrase the discriminant? It's the part under the radical from the quadratic formula. Mm-hmm. Yep. Right. This is relevant a surprisingly large amount of the time. I would say that it comes up on more than half of the Blue Book tests. I might be lying, but if I'm lying, I'm not lying by very much. But there are still more things that we can get out of this. Do you know where the x coordinate of the vertex is? Not with the discriminant, no. Do you remember our good old friend negative b over 2a? It is the x coordinate of the vertex. That's literally what it is. But there's even more esoteric knowledge that you could use, and these two things are only very rarely useful, but when they're useful, they are really, really useful. They can often let you skip all of the hard parts of a problem. Do you know the sum of the two solutions and the product of the two solutions? My assumption is probably not. The sum is negative b over a, and the product is positive c over a. So these are things that are only rarely useful, but when they're useful, oh my god, are they useful. Incidentally, this sum is actually related to this. Remind me, where is the x coordinate of the vertex relative to the two x-intercepts? So if we add the two x-intercepts and divide by 2, then we get the vertex, right? And if you add them together, you get negative b over a. And then if you divide that by 2, you get negative b over 2a. The two are actually related to each other. Incidentally, it's actually quite easy to derive the formulas for the sum and product of the solutions. They actually both just come from the quadratic formula. Like the quadratic formula is negative b plus some junk all over 2a, and negative b minus some junk all over 2a, right? If you add them together, the radicals cancel out, and you're just left with negative 2b over 2a, or just negative b over a. It works out very similarly if you multiply the two of them to get the product. Things just cancel out very conveniently. Okay. So, most important thing for you to know that wasn't 100% locked down is the discriminant. It is very nice, but more rarely useful to know negative b over 2a, negative b over a, and c over a. That said, this question right here, question 19, gets much easier if you know one of those more esoteric things. And by much easier, I mean you just skip right to the end of the question very quickly. Mm-hmm. 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 And just like that, you're done. Is the whole problem. Now, if we wanted to solve this one without doing that, I believe that we would have to turn probably to either the quadratic formula or to some very sophisticated factoring techniques. I believe that this is one that we could factor via grouping in a very awkward fashion. For instance, you could factor 57 out of the first two terms, and you could factor a out of the second two terms, and then you could factor out, I believe, x plus b out of the remainder. But I digress. Actually, do you want to just see that in action? It was a little bit too hard to follow over words, I think. So if we wanted to factor this one via grouping, what we would do would be 57x squared plus 57bx plus ax plus ab. We would factor by grouping and factor everything that we can out of these pairs. So we could pull 57x out of the first two, and we could factor a out of the other two. Then both of these wound up with exactly x plus b, so we could factor x plus b out of both of those terms to get 57x plus a times x plus b. And then we could use that to figure out the two solutions. Yep. It's a lot more work that way, huh? So these three niche pieces of information, the product, sum, and axis of symmetry, negative b over 2a, they're much more rarely useful than everything else, but they open so many doors when they are relevant that it's really, really nice to know them. It's very convenient. All right. Can I ask you to take a look at question 20? This is a question that you can get right 10 times out of 10. And we're going to want to make sure that you're able to get it right, and then we'll also want to make sure that you're able to get it right by doing math. It is the circle equation, but it's the circle equation in standard form instead of in an actually useful form. Mm-hmm. That's how to do it algebraically. That is correct. Where's 1.5x coming from? Like, I liked the 1 over 4, but I don't know about the 1.5x. Sorry, go on. Mm-hmm. But the second term doesn't change. Shouldn't the second term remain as 1x, not 1.5x? Like, to complete the square of the x's, you just add 1/4 to both sides. Nothing else changes. Yes. Where's the minus coming from? No, that is absolutely not how that works. You are confusing two different concepts. What you're thinking of right here are two different things. If you have an expression, you can add 0 to the expression without changing it. That involves doing something like plus 1/4 minus 1/4. If you have an equation, you can keep the equation the same by doing the same things to both sides of the equation. So you could add 1/4 to both sides of this equation twice. Yes, we are adding 1/2 to the far side. What do you mean by that? That is fundamentally not how that works now. Are you talking about something like x plus 3 equals 4? You subtract it from both sides. So, this is what I believe you are thinking of. You are thinking about a situation where you're completing the square without an equation, x squared plus 2x. In this situation, you would add 1 and subtract 1, and then you'd complete the square with this content. This is because we are adding 0. However, if this was an equation, you might notice that we could then add 1 to both sides, and we could have achieved the same thing by adding 1 to both sides from the get-go. So let's be very clear. There are exactly 3 things that you can do in math. If you're doing things to expressions, there are 2 things you can do. You can add 0 to a number, or you can multiply the number by 1. This right here is an example of adding 0. Multiplying by 1 is like changing a fraction into a different reframing of the same fraction, multiplying it by 3 over 3. The other thing that you can do in math, the third thing you can do in math, is whatever you want as long as you do it to both sides of the same equation. I guess more fundamentally, you could state this as you can restate numbers in different forms, or you can do the same thing to both sides of an equation. And those are the only 2 things that you ever do in math. I said, lying. Um, those are the big 2 things you do in math. Those are the main things that you can do algebraically. Hmm. Like, I'm very impressed that you know how to complete the square. Many students are really intimidated by that. Um, I think where you fell victim to is that many times students are taught how to complete the square as an expression rather than in an equation. And that's where your plus one minus one habit came up from. And then it got misplaced into this equation form. Um, Double checking, does it make a lot more sense why it works the way it does, though? Yes. Right. And you can choose to do plus one minus one on both sides, or on one side, excuse me, because that doesn't change a number. Or you can choose to do plus one to both sides because that changes both sides equally. In an equation, we'll usually choose to do plus one to both sides instead. It achieves the same result, and we don't have the clutter of this minus one sticking around. Okay. Yes. Now, what if you saw a question like this on the test again, and you wanted to make sure that you got it right, but you knew that on occasion you made mistakes with this sort of setup? What could you do to get this question right every time? Is there a way to solve this that's non algebraic? Can I ask you to graph it, in Desmos specifically? And it gives you 2 points on that circle that you can use to find the diameter. Are there 2 points that you can hover over that would definitively give you the diameter? Are those creating a diameter? Are there things that deal with like the outermost points of the circle that you're absolutely certain are on exactly opposite sides of each other that you could highlight? Like if we had like the leftmost point and the rightmost point, that would be a diameter, right? But it doesn't give us those, so instead we could turn to the topmost point and the bottommost point. Yes. Based off of those two, could you find the diameter? Right. Because those are the points that Desmos automatically shows us. I don't have a better answer for you. It's because that's what it does. I promise they were there. You did not notice it, but they were there. So, knowing that Desmos gives us an out for this question, super, super useful. It gives us a very easy way to fact check our work, or if we don't feel like completing the square that time, it gives us a way to brute force our way through it. Lovely. All right, then we're on to question 21, which is a question that wants us to do some math. I'd love to hear about your thought process for this one. Mm-hmm. I will put a beautiful sketch of that up on screen in just one moment. I'm listening. Mm-hmm. Well, it's just the area of all the sides added together, right? The advice that I give you right now is you're currently thinking of too many things. Let's narrow our focus. You mentioned that you wanted to talk about the surface area of a prism. Let's do that first. K is the surface area of a prism. How could you express that, including the constant that you're trying to find? You've got your picture. There's some more things that you should have written on your picture as well. Like you've labeled the height of this. Are there other things that you should label? Hmm. It is a square. And what's the thing we're trying to find? It's often useful to create a variable for the thing you're trying to find. What on this diagram would you label with X? Only one of the side lengths? Hmm. Times? 4 times 90x. That's a lot better. I'm sorry. Right. 2x squared plus 4 times 90x is equivalent to? Right. So now that you've narrowed your focus, you've been able to create a potentially useful formula. What should we do next? Mm-hmm. Um, that is one way you could do it. Could you also just create a formula that would tell you what's equivalent to 92 over 47k? It should not equal 2 times k. Because as you noticed, these small areas in here are no longer part of the surface area. Can you write it in terms of x? Is it 4 times 90x? How tall are the cylinders now? Or how tall are the rectangular prisms now? Are they still 90 tall? So 4 times what x? Right. And how many of the x squared sides do we have? Right. So now we've got two equations. K equals 2x squared plus 4 times 90x, and 92 over 47k equals 2x squared plus 4 times 180x. Now that we've got two equations, how could we figure out the value of x? That is true. Yep. You would have to distribute things out before you subtract, yeah. Sure. It depends on whether you'd like to work with fractions or not. Then I think multiplying by 97 is a good choice. You should probably do that. We're going to be distributing things out at some point. Like at this point, it's just a one variable quadratic, right? We just have to get everything to one side of the equation. Oh, excuse me. So you just distribute things first. Yeah, I don't understand why that's so surprising. There are a lot of numbers. Is that how you solve quadratics? You usually solve quadratics by factoring, getting everything onto one side of the equation, and then factoring. You never had one. That's good. If we had a constant factoring, this would be way harder. You can just factor 90x out of both terms, right? I would be surprised if it had a negative side length, yeah. Okay, so you've gotten to the right answer. But this question was a slobber knocker. Like, we did a ton of work. Is there some way that we could have done way, way less work and gotten to the right answer way, way more easily? Do you know a method to solve any system of equations while doing no work yourself? That's right, it's Desmos. Replace k with y, slap both of these equations in Desmos, and find the intersections. That would have saved you a lot of work, huh? So, we don't want to turn to Desmos to solve every problem, but we do want to turn to Desmos when it's a better way through the problem. This question gets way easier if you're willing to solve it via Desmos. I am mildly concerned about how difficult setting up these initial two equations was, though. For a student in your place, setting up the equations usually is not a super hard part of the problem, and I wasn't able to get a super good read on why setting it up was so difficult for you. Certainly, one big hurdle was that they never told you that the side lengths of the square are x. Um, So one major place where you need to update your heuristics is you want to make sure that you are assigning some sort of variable to the thing that you're trying to find. But another major issue seems to be that you drew pictures and you didn't get a lot of use out of them. Because drawing pictures is absolutely what we want to do here, but it looks to me like you might have drawn your picture in a way that didn't do as much to help you set up your formulas as it could have. Like, when it comes to using the pictures that you drew, of course, the big one is that we didn't annotate these side links with X without a lot of prodding, but you also, it sounded to me like you didn't note that this side was 180. And my impression is that you did not draw these as translucent, which could have more easily helped you see that there are 2x squared, and the same thing remains true for the larger one as well. You also asked, when you were thinking about like deducting the middle area, you asked whether we were deducting 1x squared or 2x squared. And drawing it in a translucent fashion would have helped you more easily see that it's 2x squared. You'd be deducting the top of the lower rectangular prism and the bottom of the top rectangular prism. Both of those are overlapping, and they are both not included in the new surface area. That is, incidentally, another reasonable route through this, understanding that 2x squared is equivalent to 2/47 of k. (92/47), so 2k squared is 94/47. And the missing part is 2k squared. So we added these two together, which would normally have surface areas of 2k, but then we took out 2x squared, and we wound up with 2/47 less area than it would have had if they were unattached from each other. That's a very high concept route through the question, but it could theoretically get us through this more easily. Well, that's a bit of a misnomer. It could let us get through this question with less math like this. Whether or not that means easier is debatable, because the thought process to make that assertion is much more challenging. In any case, I think the biggest takeaways are we want to iterate on what we were doing to set up the equation. We want that to be a little bit cleaner. And the other really big takeaway is we should have used Desmos. We really should have used Desmos. It would have made our lives a million times easier. Okay. What do you know? It's another quadratics problem. Oh, this is one of my favorite questions. This question is so cool. So, you might remember how we talked about quadratics at the start of today. These hard quadratics questions show up on pretty much every test, and they expect that we know pretty much everything about quadratics. We won't have to use all of it every time, but we might have to use any of the things that we reviewed. So, one thing that I would like to tell you as a general hint is that it is often useful to write a quadratic in factored form or vertex form, and then return it to standard form. I'm going to ask you to talk through your thought process given that hint right there, but I expect that I will have to give more hints later in this problem. Mm-hmm. Right. Where's 2ax coming from? Shouldn't that be minus 18ax? That makes a lot more sense. Do also note that that would be plus 81a minus 14. Oh, it is. Yeah, you're right. It's 81a. Now, the really important thing about this is that by doing so, you've now been able to write A, B, and C in terms of A. In other words, you can write the thing that the question is asking you for just in terms of A. Well, let's talk this through. This is equivalent to ax squared plus bx plus c. A, in terms of A, is just A, right? Could you tell me what B is in terms of A? It's negative 18a. It's the coefficient of x, right? And then C is a little more exciting. Go on. Minus 14, but yes. Now, given this, could you tell me the value of A plus B plus C in terms of A? Mm-hmm. Right. And now that we've got this expression in terms of A, we can start thinking about the correct answer to the question, but we would have to use a piece of information in the question that you seem to have not yet noticed, and we'll have to understand the ramifications of that as well. Yeah. That is true. And you could theoretically use the discriminant in terms of A to learn some things about A given that. Well, you've learned what those are in terms of A. If you learn things about A, you learn things about all of them. The discriminant is often a good choice here, but in this case, we can actually get what we need via drawing a picture. I can ask you to sketch a little picture of this parabola with a vertex at 9, negative 14 that intersects the x-axis at 2 points. In order to have a graph that looks like that, something has to be true about A. Right. And that's all the information that you need right here. If A plus B plus C is 64A minus 14, and a is greater than 0, then which would be the value of 64a minus 14? A does not have to be an integer. It does not say that A has to be an integer anywhere. The question from this point is very much not like what is the sum of these, it's which of these answer choices could be the sum of this. The answer choices should very much be part of your thought process at this point. That's one way to think about it, and that will get you to the right answer. It's possible to proactively choose the right answer otherwise, but I'd like you to, if you're going to take an elimination process, I'd like you to start with an answer choice that's in the middle. Because if you just start with B or C, you should be able to figure out if you should be plugging in a larger or smaller number, right? So you could do less total elimination. And should you be plugging in a larger or smaller number? I'm not saying. Technically, that is a larger number, but I digress. In other words, you do need a larger number, and you were thinking of a number with a smaller magnitude instead of a smaller number, which are two distinct concepts. Right. So conceptually, if A is greater than 0, then is 64A going to be greater than 0, equal to 0, or less than 0? Right, it's got to be some positive number. In other words, will 64A minus 14 be greater than negative 14? Or sorry, will it be more positive than negative 14 or more negative than negative 14? And what is the only answer choice that is more positive than negative 14? Right. That's the thought process that gets us where we need to go. Okay. These tough quadratics are tough. They're usually going to ask you to not only have comprehensive knowledge and fluency with your quadratic formulas, but they're also going to ask you to employ some very flexible thinking and experimentation. These are often among the hardest questions on the test. I want to make sure that we get our sessions for this coming week scheduled. I've heard back from Shannon, who is the tutor manager. Shannon is checking in with the team. I've let them know that please, if you could get back to us by Monday, that would be really, really nice. But they'll probably be reaching out to you and your family at some point. If you don't hear back from them, please consider reaching out on your own. I'm going to schedule our sessions this next week I trust your family is going to pay. I have not seen any evidence to the contrary, so I will happily hold our sessions, even if we haven't managed to muddle our way through this by next week. If you are looking for early sessions, we have a dearth of early sessions this coming week. The earliest sessions that I have this coming week are currently 5 p.m. EST. Mhm. Mhm. We could indeed. This Tuesday, the earliest session that I have is 7 p.m. EST. Is that an acceptable choice? Okay. This Friday, the earliest time that I have is 5 p.m. EST. Is that one good for you? Okay. Yes. My apologies for the changing time slots. They have to do with the moving group classes that I can't do anything about. So let's see. So 7:15 at 7 p.m. EST. Actually, I keep realizing that I never double check where all of my students are. Just out of interest, can you remind me where you are in the country? Got it. So we actually are working in your time zone. That's convenient. Okay. And then it looks like our big takeaways from today were largely that there's room to grow in the hardest quadratics. Everything else looked quite strong to me. The hardest quadratics looked like those questions are pretty commonly going to be pretty rough, and there are a few useful small things for us to learn about them. Okay. Um, in addition, we've got two major choices for this coming week. If you want to keep getting timing practice, we could keep working on and reviewing blue book tests like this, and I think that's a reasonable choice. Or if you would like to do some focused content on some specific topics, we could aim for me to pull out some of the content maybe from my personal business on either these very hard quadratics or some of the trickier um, analysis questions. Do you have a strong preference of which one you'd like to shoot for next time? I strongly agree with that. Go on. Something that I'm going to recommend to you is something that I will include in the wrap up email. But I do think that having practice tests to work off of is very important. And I think that the Princeton Review, um, which has like a $12 Kindle ebook, very cheap, comes with 5 really, really high quality practice tests. I think that we have been a bit cavalier about how quickly we have run through these practice tests. I think if you aim to do everyone or one every week or every other week, that would be a much better decision. Although, if I remember correctly, a lot of your issue is just that you've been burning through material because you finished all of Prep Scholar. Is that right? Or am I confusing you with another student? Yeah. Okay. Yeah. Yeah. For what it's worth, you should make sure to do it. That qualifies you for the score guarantee, and you've certainly put in the work for that. um, that's something I was going to say. I think that in our subsequent sessions, we will probably pull out a fair amount of material from my personal business as well. But I did want to make sure to put that Princeton Review stuff in your hands, since that is another 10 hours of genuinely very high quality study material. Um, you don't should not feel compelled to work on that by our next session. I am making a note right now